Welcome back. This is All This Math. I'm Professor Parker. Make sure you're subscribed to the channel. Make sure you like the video. Make sure you share the video with somebody. And if you got questions about anything I try to explain, make sure you put your questions down in the comments. All right. Or if you just got comments about anything I explain, put your comments down in the comments. All right. Now, I call this a tedious equation because I try to stay away from words like difficult, hard, complicated, complex, right? It's more tedious than anything. It involves a lot of steps, but as long as you know the steps, all you got to do is apply the steps, right? And I'm here to show you what the steps are. All right. So, first, let's take a look at the equation. Let's read it, right? Let's read it correctly and carefully, and then start attempting to solve it. So, we read from left to right. We got A times the quantity of n plus y is equal to 10y plus 32. You know what I just realized? I made a mistake. I did not provide the instructions. How are you supposed to know what this? How are you supposed to know what to do with this? Are you supposed to solve for A? You're supposed to solve for N? You're supposed to solve for Y? What are you supposed to do? I forgot to write the instructions. The instructions are to solve for Y. Those are the instructions. Solve for Y. All right, so we're going to solve for Y. All right, that's key. You got to know what you're expected to do. All right, or else it is going to be difficult if you don't even know what you're supposed to be doing. All right, now if I want to solve for Y, first I got to take a look at the problem. I got to realize I got Y's in two different places. I got a 10Y over here on the right side of the equation. The equation is divided into a left side and a right side by the equal sign. All right, so we got a right side, we got a left side. Right side, left side. So we got a 10Y on the right side. We also got this Y right here inside this group with N on the left side. We need to get those Y's together on one side of the equation. What I would do is, in an equation like this, I would get rid of these parentheses, right? So that way this Y term can be exposed, right? And not enclosed within this group. Now, how do you get rid of the parentheses? By distributing the A. So A times N and A times Y. That's how you can get rid of the parentheses. So I'm going to do that. And then we rewrite the equation in simplified form. So we got A times N, which is just AN. We got A times Y, which is just AY. And it's plus AY because it's positive. A times Y is AY. Bring the equal sign down. The right side don't change. Nothing on the right side changes. All right, so we got 10Y plus 32. All right, now, remember the goal in the game plan. We're trying to get this Y term and this Y term on the same side as each other. So what I'm going to do next is I'm going to do something that I call, not just me, but people call transposing. Transposing. That's when you take a term from one side of the equation and you move it to the other side of the equation. So this 10Y, it's on the right side. I'm going to move it over to the left side. But when you do that, you got to change the sign. You got to change the sign. All right. So it becomes a negative 10Y. All right. So this 10Y, watch this, right? This 10Y is going over here. This look like it's almost dead. And then this AN, because I want the Y terms alone, right? I want the Y terms together by themselves on one side of the equal sign. So then this AN, that's got to go. That's going to go over there. All right. So let's see what it's going to look like now. So now we got AY minus 10Y. Why? Because the AY was already over there. AY was already over there. It was positive AY. It was already over there. It's still positive AY, right? Now we got minus 10Y. It was positive 10Y on the right. When it moves to the left, it becomes negative. The sign changes. Whenever you transpose, whatever term you transpose, the sign changes. The sign changes. Then we're going to have negative AN plus 32. The positive AN was on the left. When we move it to the right, it becomes negative AN. The positive 32 was already over there. All right. So whenever you're solving equations, make sure you know and can take inventory and take an account of every term, right? Every term. Like, how did this AY get right here? Well, it was already over there. Because look, it says plus AY. I just brought it down. How did this negative 10Y get over here? Oh, because it was positive 10Y on the right. I moved it over to the left. And when you do that, you got to change the sign. How did this negative an get over here? Oh, well, it was positive an on the left, but I transposed, just like I did with the 10y, I moved it to the right side. So the sign got to change. Whenever you move from the left to the right or the right to the left, the sign got to change. If it was already negative, it would have turned positive. If it's positive, it's going to turn negative. So this an is going to become negative an. Where'd this 32 come from? Oh, it was already over there. Plus 32 just dropped down. All right, another thing I want to say is this. It wouldn't have made a difference if I'd have wrote it as negative 10y plus ay. As long as they're on the same side, as long as they're over here with the correct signs. All right, well, just like over here, I could have wrote 32 minus an, right? Now, I call this tedious because it requires a lot of steps. Now, if nobody ever told you how to do this, you won't know how to do it, but I'm going to tell you how to do it. Now I'm trying to solve for y, right? Notice that there's a y term in both of these terms. Well, there's a y variable in each of these terms. That means that y is a greatest common factor. That means I can factor out the y. That's the next step. So we're going to have y as a GCF using the GCF method. And then we're going to have a minus 10. Now, where does this a minus 10 come from? And if you watch my channel, if you're familiar with my channel, you're a regular, you know what I'm saying, come in here, you've been subscribed for a minute, you know I'm very big on explaining things. Because one thing I hate sitting in math classes where teachers, professors, whoever, whatever level, just be doing problems on the board and do not explain why they did what they just did. I cannot stand that for real, right? So I'm very adamant about talking about, especially in this space, because we got time, right? We got enough of a space and opportunity. We got time to talk about like where did that a minus 10 come from, right? So if you're a teacher watching this, don't be one of them teachers that just like try to look all smart and just doing problems on the board and just hoping or assuming that your children or your students just going to know what you're talking about, right? I mean, maybe if you already have explained it and you want them to think more independently at that point, by the time, you know, it's later on in the lesson or whatever, right? And you want them to do the problems and to be more independent, you know what I mean? That's different. But first time out, first time they ever seen this type of problem, and you ain't even going to explain like where the a minus 10 came from. And don't just assume that they should know, because there might be somebody in that room that don't know. All right, so anyway, where does the a minus 10 come from? If we use the GCF method, we understand that y is the greatest common factor of both of these terms, because y is common. So that's why we write the y out here, and then we put the parentheses, and we're going to have a binomial, right? Then you take each term and divide it by the GCF. So ay divided by y is just a, because y divided by y gives you 1. Whenever you divide something by itself, your quotient is 1. So then you take that a that was there, multiplied by the 1 that's left. A times 1 is just a. Then you do negative 10y divided by y. The y's cancel out. Some people will say divide out and give you 1 again. So then you have negative 10 times 1, which is negative 10. Right? So you got y times the quantity of a minus 10 is equal to negative an. Don't none of this change. It's over here on the right side. This don't change. Right? But now we want to get, our ultimate goal was to solve for y. So that means we're going to get y by itself. Meaning when we solve for y, we want to know what the variable y is equal to in terms of all of these variables and this constant 32 and coefficients and all that. So what do? We got to get rid of a minus 10. How do you get rid of a minus 10? Well, what is a minus 10 doing per se? A minus 10 is being multiplied by y, because that says y times the quantity a minus 10. So whenever you want to get rid of something when you're solving an equation, you got to do the opposite operation. So the opposite of multiplication is what? You said it, division. So you're going to divide by a minus 10 on the left side, but in solving equations, we got to be balanced. Just like how we're going to, let me see, did we do anything over here like that? Nah, okay. Yeah, but we're going to divide by a minus 10 on both sides. And what happens when we divide a minus 10 by a minus 10? They divide out and turn into ones. And what's 1 divided by 1? 1 divided by 1 is 1. And then 1 times y is just y. So then we have y is equal to this over here. Negative an plus 32 divided by a minus 10. So we just solved for y. Y equals negative an plus 32 over or divided by a minus 10. Now, what was different about this problem? Well, we had to distribute. We had multiple terms with y in it. We had to get them together, and then we had to factor. So we had to distribute, transpose, and then factor. Oftentimes, you won't have to factor when you're solving a linear equation, but in this case, you did. Especially, I want you to be on the lookout for that. Whenever you are solving for a certain variable, and the variable is represented in two different spaces in an equation, there's a strong chance you're going to have to factor out a GCF and use the GCF method to get the variable by itself. There's a strong chance that's going to happen. All right. So just be aware. All right. But the key to these types of problems, you got to practice them. You got to do them. So it breeds familiarity. So you're familiar with these types of problems. So you don't got to get intimidated when you see it. You got to do the work. You got to do the practice. You got to do the problems, right? You got to do the problems. When you do the problem, like this is easy for me because I've done a lot of these problems. If I hadn't done a lot of these problems, it wouldn't be so easy. I wouldn't be in flow state with these. You know what I'm saying? So just put the work in. You know what I'm saying? That's all you got to do. And like I said, these are tedious, meaning they require a lot of steps, but they're not difficult. They're not hard. They're not complicated. They're tedious. There's a difference, right? There's a difference between tedium and difficulty. All right. This is tedious. Make sure you know the difference. All right. So go practice some problems where you got to solve for a variable that's located in two different places. And it's a lot going on, like in this problem. And there was other variables too. So yeah. All right. I'll see you all in the next video. Peace.